Good day to everyone. My name is Dr. Ahgalya Subbiah from Faculty of Information Sciences and Engineering and Management and Science University, Malaysia. Today, I will be presenting a paper titled Gamified Education Tools for Mangrove Conservation, a co-creation case study on student engagement and technological integration. This work is a collaboration with my colleagues from MSU as well as from the University of San Agustin in Philippines in partnership with local conservation group. Mangrove ecosystems are critical for our planet. They act as a natural ecosystem barriers, absorb storm impact, store large amounts of carbon, and provide habitats for countless species. But they are under severe threats from human activities such as deforestation and coastal development, and from climate change effects like rising sea level and extreme weather. Many young people today express concern over the environment, but our research and others shows a clear gap between simply being aware and actually taking action. Current educational approach often lack of interactivity and engagement needed to sustain their interest, especially for those students who have grown up with a highly digital world. This is where emerging technologies such as gamification and IoT can help, making conservation learning interactive, data-driven are more likely to inspire real behavioral change. Based on the challenges we identify, our study had three main objectives. First, to assess current level of awareness, attitude, and engagement preferences among students regarding mangrove conservation. Second, to identify knowledge gap barriers that prevent students from moving from awareness to active participations. And finally, third, to design and propose a co-created gamified IoT-based tools which we call Mangrove Munchkin, that can transform learning into sustained conservation action. Today, together, this objective from the foundation of our approach, where students are not just recipient of knowledge, but active contributor to the conservation solutions. Globally, conservation efforts are underway. For example, the Global Mangrove Alliance aims to expand mangrove habitat by 20% by 2030. By developing countries, conservation faces persistent challenges, limited financial resources, socio-economic pressure, and competing land use priorities. Research also shows people engagement in environmental issues shaped by their cultural, social, and economic background. Among youth, there are recurring action gap that they may know about an environmental problem but still lack of active involvement. Innovative methods have been explored. Gamification has shown to make learning more interactive and engaging by using rewards, challenges, and immersive experiences. IoT integration also has proven effective. For example, the TPILS project, for instance, use IoT-based smart planters and gamified tags to improve environmental awareness, and similar approaches in energy education have successfully influenced behavior change. However, several barriers remains. Accessibility, technology literacy, and curriculum alignment are not fully addressed. Our work responds to this gap by combining gamification, IoT, and co-creation into a single context-specific approach for mangrove conservation education in Malaysia. We adopted descriptive and explorative research design to assess awareness, attitudes, and engagement preferences related to mangrove conservation. Our our sample consisted of 200 students aged from 13 to 17 from coastal regions. We used stratified random sampling to ensure participation representations of across age, gender, and social economic status. Refer to the chart, 45% were in the age of 13 to 15 age group, 55% were 16 to 7, gender split was almost equal, and social economic background ranged from low to high income. We obtained ethical clearance, informed consent from all participants, and parental consent for the minors. This ensured that our research met both ethical and academic standards while capturing diverse perspective to relevant to conservation education. Our survey consists of 20 questions grouped into three main sections. First, 6 questions on awareness of mangrove, covering the ecological role and main threats they face. Second, 7 questions were on attitude towards conservation, asking students to rate the importance of mangrove and their willingness to get involved. And third, 7 questions of preference for digital and gamified learning tools, including whether they are interested in learning through gamified game apps. We use mix of multiple choice questions such as Likert scale rating and few open-ended prompts. Before rolling out to this full survey, we conducted pilot tests with 20 students to ensure clarity and reliability and made adjustment based on their feedback. Our results reveal both challenges and opportunity. First, only 45% of students could correctly identify threats to mangrove and just 20% showed high overall awareness. On the positive side, 75% expressed interest in engaging with interactive game-based learning. Statistical stats gave us further insights. Gender differences, on the differences, female students have significantly higher awareness than the male students with P less than 0. With P less than 0.05. And from the age differences, older students showed stronger conservation attitude with P less than 0.01. And finally, on the social economic factor, higher income students were more likely to prefer digital tools with P less than 0.05. These findings tells us that one fits all approaches won't work. Engagement strategies need to be targeted and adapted to different group for maximum impact. Our structural equation model confirmed two strong relationships. First, environmental awareness has positive impact on conservation attitude with a coefficient of 0.65, and the results is statistically significant with P less than 0.01. Second, awareness of also influences preferences for gamified tools with a coefficient of 0.57, again statistically significant at the P less than 0.01. The model fits is strong with a comparative fit index of 0.92 and root mean square error of approximation of 0.05. In simple terms, this means when we raise awareness, we not only improve conservation attitudes, but also we increase the likelihood that students will adopt technology-based learning tools. Based on these findings, we have designed Mangrove Munchkin, a gamified IoT-enabled learning platform that connects digital activities with the real-world conservations. Students can take on interactive challenges such as identifying local mangrove species and tracking pollution levels and completing sustainability quizzes. This app linked to an IoT sensors plays in actual mangrove areas, providing a real-time environmental data, for example, water salinity, temperature, and soil moisture. Player can earn points and reward for completing challenges, and when they can redeem for recognitions or conservation related initiatives. This isn't just a virtual game. It builds a collaboration with Si Jangkang Mangrove Conservation in Kuala Selangor, so the student also can join on-site field exhibit activities that directly contribute to the mangrove conservation. In short, Mangrove Munchkin blends the fun gaming, the power of live data, and the impact of hands-on conservation. This study offers three main contributions. First, in our context integrates IoT and co-creation approach for mangrove conservation education. Second, it builds on evidence. And third, it provides scalable models that can be adapted on other ecosystem communities on both locally and internationally. In practical, this work gives educators and policymakers a new way to embed environmental conservation into schools curricula in a format that actually resonates a digital native to students. By combining technology, interaction, design, and local collaboration, we can move from raising awareness to inspiring sustained conservation activities. In conclusion, gamified IoT learning can bridge gap between simply knowing about conservation and actually taking actions. The co-creation approach ensures that students are not generally passive learning, but active contributors building ownership, commitment in long-term engagement. Thank you.